Okay, so I'm Okhandier with Mlogica. We are a big data company. And main topic for this is the smart cities will eventually get to have a... Okay. How about now? Mlogica is a big data company. We work with larger scale companies. We're a big data consultancy company, and we produce our own big data platform as well. But the main topic for this is smart cities and the fact that they are going to have a lot of data, a lot more data than we currently really deal with at a reasonable time or fashion. So instead of calling it big data, we're going with hyperscale big data, just to clarify the difference. So big data itself is we're expecting mixed data types. The common idea is that we have structured data, we have unstructured data. Most of the data that we deal with on a daily basis is structured, and but that's really only 20% or so of the actual amount of data that's out there that we could be using. So we're not making use of all of it. So now we're looking towards big data and correlating between all of this unstructured data that we're currently dropping the ball on, and we can do the correlation across various forms of unstructured data to find hidden correlations and for further optimization that we don't do today. 3 V's of big data is volume, velocity, and variety, but the big problem is that the vast majority of our big data tooling, they tend to scale somewhere around to 50 terabytes a day ingest and about a petabyte worth of data being stored before you start seeing all these problems where you can't actually manage the data anymore. You can't query the data in reasonable time. You start looking at 24 hours, 48 hours, week-long response times before you actually get any analytics out of it. And if you're, well, go to the next slide. So once you start reaching that point, you end up with you aren't getting the benefit of being able to optimize or to do real-time optimization with the data that you're collecting. So you can only start doing these longer scale things where it takes a month to actually implement any changes you want to implement. We've coined hyperscale. So in practice, what we found was that 50 terabytes a day and 50 terabytes a day ingest and about a petabyte worth of data. That's where companies start to have these problems where they're not able to manipulate it in any reasonable time, and then they come to us. So we just drew a line. Under 50 terabytes, we tend to see the big data tooling works fine. We don't need to challenge that market. They're doing fine. Hadoop, Snowflake, and so on. They're able to manipulate and deal with the data in reasonable fashion. You can scale up to that point. But it's after that where we start to see problems. So that line we're calling hyperscale is above it, and normal big data is below it, and that's where most of the market is today. So we would like to have hyperscale data when we're dealing with hyperscale big data. We would like to have it be operating in real time and high speed. We would like it to be handling mixed data. It should be unstructured, semi-structured, and structured data, and we would like it to be fairly capable of all the kinds of analytics that we would like to be doing. And in-memory is a solution that is used by like SAP HANA, tends to hit the hyperscale market, but it's mostly in-memory data, and it's an in-memory database, and it's extremely expensive because of it. So ideally, we wouldn't actually... In-memory is a solution, it's just not... purely in-memory is the solution. It's not the solution we really want to have. It doesn't scale in cost. It scales in. That slide. So then we have IoT data and we have smart cities. So the whole point of IoT data is that we have a bunch of these sensors lying around and across all our buildings, across all our utilities, and so on. And each individual device will produce a simple, reliable stream of data. But once you have a billion of them, then it becomes a complete mess of when data is coming in and what rates, and what kind of data that you're looking at, and essentially you're just looking at a sea of data. And when you're talking about smart cities, you're putting that IoT devices everywhere. it's not a simple problem. When you scale from when we scale from these demos of IoT devices, or like the current setup is fairly limited. We have a few IoT devices. We imagine a smart home where it's just a couple devices, or you have a few of your appliances are now more intelligent. But when you try to scale up to like the whole house or the whole infrastructure of the entire city, it becomes a much more significant problem where we start to see that limit that we're looking at for where we have big data versus hyperscale. We will very quickly reach hyperscale and then beyond. So we have to resolve that particular issue. So just some examples of it. The surveillance cameras worldwide are generating 2,500 petabytes daily data. We have 4 petabytes per month from just people calling, texting, tweeting. If Facebook has 4 petabytes daily created. We have a bank with just transactional data, purely structured data that they've collected. They've got 30 petabytes of it that they can't actually analyze in a reasonable time. And then they've got another 100. They've got hundreds of petabytes of mixed data that they just don't do much with. And we have at least one 3-letter agency who are now talking about exabytes of data. So the smart cities, so like a smart factory will have 5 petabytes of video data daily. And the idea with smart cities, the idea with IoT is that we want to have this tight feedback loop where ideally, as soon as we get the analysis, we start to manipulate the environment. As soon as we manipulate the environment, we get the new analysis so we can manipulate it further. So instead of having this generated model that we're manipulating as a simulation and then trying to apply to the real world becomes the effective model. It becomes the simulation itself. But the only way that functions is if you have that real-time feedback loop. It has to be that when you collect 5 petabytes of data, you have to analyze it immediately. And if you can't do that, we'll never actually see the ideal optimization opportunity that we're looking for out of smart cities and IoT. So some more examples of so this factory is just they're doing 1.2 petabytes daily, just generated. This was a smart meter. If you have 30 million sensors just generating every 15 minutes, you're still looking at a trillion records yearly. And with the flight engines, you're looking at 20 terabytes of information generated every hour that they're in flight. So it's the twin engine, it's 40 terabytes for a single plane going on a 1-hour flight. So when you're looking at these things, if what's really going to be happening in practice today is that we generate the 40 terabyte, we drop most of it, and then we can do whatever analytics that we can. But that's not the goal. The goal is to be able to make use of all of it, and we want to make use of all of it because humans themselves are not very good at correlating that data, and we want the machine learning algorithms to do that for us. But they can't do that if we can't actually process all the data that we have. So this is the plug. We solved it, or rather, we managed to hit hyperscale data collection. We can hit we've tested up to our system. MCAP it's a database that's capable of hitting 3.3 petabytes daily ingest, and it can do a sub-second query response time against 20, 30 petabytes of data with a SQL interface. Not that. So it scales from 100 terabytes to 30 terabytes or to 30 petabytes. Our 3.3 petabytes is an on-prem solution. In the cloud, we're seeing more like 72 terabytes per day, but that's mostly a function of AWS doesn't actually have the hardware we were looking for. They will have it in the future. And then what we sell is it as a appliance that's pre-configured. It's pre-configured and it's built for the client for the particular use case. And we can at least scale up to 12,000 nodes in a single cluster. We haven't tried further than that, but it's fairly linear up to that point. So yeah, with one of our test cases, we had a petabyte of sensor data. We had 40 terabytes of mixed data, and we had some. So we had a petabyte in general, and we were still looking at sub-second response times. And then it solves it mostly because of it's able to break up the way it ingests the data and manipulate, and it optimizes on it's able to handle efficiently different forms of data, and it breaks it down into channels to do so. And there's some secret sauce in there that makes it fast. And then eventually, the other part of it is that it's able to map the unstructured data very efficiently into semi-structured based on user-defined data types and functions. Really, that's it. One thing I actually forgot was I wanted to mention that part of the solution is that it's a columnar database, which is fairly normal, but it's also columnar databases are not special, but they're absolutely required for IoT, just because columnar databases specialize on, or they optimize for low cardinality data. And as our data gets bigger, and as we collect more and more data, it will always get more homogeneous over time. The more data we have, the more homogeneous the data set will be. So we also end up with seeing things like 90% compression rates, and we can reduce the number of indexes we need just because we're looking at it as a column instead of tuple-wise, as relational databases tend to, or like Hadoop tends to look at it with without caring too much about the structure of the data. That's how it handles the fact that it handles unstructured data is by not handling structure at all. It just really cares about a bag of bytes. But that means it loses all the optimization opportunities for the fact that there is actually a lot of structure in the data that we're dealing with. It just happens not to all be the same. The schema may not be static. So I guess that's it.